All right, so in this video, we're going to go through how to figure out whether a geometric series is convergent or divergent. In the beginning, I'm just going to go through, what the parameters are for figuring that out, as well as the general form of a geometric series. If you want to skip straight to worked out examples, you can skip ahead to that part of the video. I'll have a time code somewhere, either as a pinned comment or on the video itself. Okay, so at this point, you guys should be familiar with knowing what a geometric series and a geometric sequence is. In Algebra 2, you should have learned this formula, figuring it out a specific term within a geometric sequence. This was introduced when you wanted to figure out what the sum of a set amount of terms in that sequence is. So at this point, this is mainly for AP Calculus students or Calculus 2 students in university. I'm assuming you already are familiar with a series as well as the terms convergent and divergent and what those would mean. So I'm just going to go over this. The telltale sign for you're dealing with a geometric series is you have some number, some constant term, raised to an exponent that has a variable in it. All right, that is the marker for what is a geometric series or geometric sequence, right? Now, what makes a geometric sequence kind of unique is that with a lot of geometric series, with a lot of series, you're able to tell whether it converges or diverges, but you're not always able to tell what it converges or diverges to. With a geometric series, you're able to get that piece of information. So here's kind of the form we want to go for. The ideal thing is to always have a constant up front multiplied to a constant raised to a variable power. All right. If we can get it to that form, it's super easy to tell whether it converges or diverges. This R is commonly known as the common ratio, or just ratio for a geometric series. So if the absolute value of that ratio is less than 1, your series will converge. If the absolute value of this ratio is greater than 1, your series will diverge. And this is for obviously infinite series, right? Where you start at a certain integer and it goes towards infinity. Now, figuring out when where a series will converge to, if it does, is done by this very simple formula. It's the first term in the series over 1 minus whatever your ratio is. All right? Now we're going to look through some examples of this. Okay, so first we have something simple here already in the form that we're looking for. All right? So we know this is a geometric series because we have the exponent containing a variable. So we have the constant out front, 3 times 2 over 6 raised to that power, meaning this must be the rate. So we have to check our conditions. The absolute value of the rate, is it greater than 1 or less than 1? So since the absolute value is less than 1, we can figure out, okay, this is a convergent sequence, right? Right? Now we're able to figure out, okay, what does this sequence converge to? So first we need to find out what our first term is. Our first term is going to be when n equals 1, what does this value come to? So we have down here 2 over 6 raised to the 1 minus 1 power multiplied by 3. And that's just going to come out to be 3. It's trivial to see. So it's going to converge to 3 over 1 minus 2 over 6, which simplifies to 1/3. And just simplifying that down, 3 over 2 over 3, we'll find that it converges to 9 over 2. All right, now let's look at a trickier example. So you might have heard a professor or teacher say that the hardest thing about calculus is the algebra, and it's going to become very apparent through a few more examples that we try to take on. So here's an example of something that looks like it can turn into a geometric series, but it's not in the form that we need it to be, right? But the way we're able to tell it's a geometric series is the constants are the bases, while the variables are in the exponent. So what we do is try to manipulate this. We want a single exponent, right? So all I'm going to do is try to shift this a bit. Let's see, the denominator can be split up, right? That's a common algebraic rule for how to deal with exponents. So I have now 4n over 3 to the n times 3. And now I can take out a 1 over 3. And from here, since I have this common exponent, I can almost take it out and rewrite this fraction with a single exponent, right? And I end up with the series from 1 to infinity of 1/3, 4 over 3 to the n, right? And now that's the form we want, right? We have this here, where we have a constant term multiplied to a constant raised to some exponent with a variable in it. So now we just check, what's the common ratio, right? What's the actual rate? It changes at 4 over 3. Absolute value of 4 over 3 happens to be greater than 1, meaning this series diverges. All right, and like I said, the easy part is just checking these conditions, right? Once it's in this form, all we have to check, all right, is the rate greater or less than 1? And if it's less than 1, we can find the what it converges to. That's the actual calculus portion of it. How to get there is a complete algebraic approach, right? You have to be super strong in algebra. It makes calculus so much easier. All right, next example. A little bit harder. Okay, so we have an infinite series starting from 3 going towards infinity of 4 to the n plus 2 to the n in the numerator. Then in the denominator, 3 to the 2n plus 3. Okay, so now we're going to need some manipulation here to get it into the form we want. So we recognize, all right, exponents are where the variables are. We can try to get this into a geometric series. So here's the manipulation I'll have to do. First, I want to fix this denominator. It has too much stuff in it. I want to split it up the way I did with the last question. And anytime I write the sigma, just assume it's an infinite series that, keeps that stuff. So this is going to be equal to that same series, and then 4 to the n plus 2 to the n over, and the way I'm going to split that up is 3 to the 2n times 3 to the third. Okay? Now from here, this is a common rule with fractions. I'm able to split this up into 2 separate fractions. Okay? Now, if you're not already familiar with this rule, with the sigma notation, it should be familiar from when you should have already done integration. right? So I split this up, 3 to the 2n, 3 to the third, plus 2 over n over 3 to the 2n, 3 to the third. Okay, now that 3 to the third is going to become a 27 we're going to factor out later, but here's how we can split this up to make it easier. So if we have the sum of something plus something else, we can split it up to become the summation of the first thing plus the summation of the second thing, right? Again, very familiar from when you did integration, right? Same rules apply, almost. Now, from here, we're going to check each one of them and see whether they converge or diverge. If either one of them diverges, then this whole thing from the beginning will diverge. If both of them converge, the entire original series converges. Okay? So what I'll do is I have a 27 here. I'll just factor that out, right? I have a 1 over 27 multiplied by 4 to the n over 3 to the 2n. And then I have this common n term, right? 1 over 27 times 4 over 3 to the second to the n. Now, let's see whether this converges or diverges. Our common ratio is 4 over 3 to the second. Absolute value of 4 over 3 to the second happens to be less than 1, right? Because 4 over 3 to the second is the same as 4 over 9. Meaning this series converges. So now let's check to see if this series converges. So we have to the n, and it's virtually the same steps, right? 27, and then 3 to the 2n, and next portion, 1 over 27 equals 2 over 3 to the second to the n. And I think it's, trivial to see whether this converges or diverges. All right. Now, one thing that I think is important to note is when you do the figuring out what it converges to. All right. You're able to figure out what each of these converge to. Right, so let me just keep the plus sign here. And what they each individually converge to, you can add them together to figure out what the original series will converge to. But here's the thing. We currently have 1 over 27 on the outside, right? Typically, you're used to that just already being your first term because many series will start at 1. This particular series does not, okay? It starts at 3. Its first term is when n equals 3. So I'll leave that for you to do on your own. The way you figure out what the first term is, always input this number in order to figure out what your first term is, and then you would put in your rate as you normally would. All right? Now, for the last example, we're going to go through right here. All right, it has the same kind of scenario. It starts at 3 and goes towards infinity, right? It doesn't start at 1. Always check to see what you kind of start at. So, again, variables in the exponents. We can try to change it to the form of a geometric series. So this is where your Algebra 2, Algebra 1 skills would come in. We have n to the negative, 9 to the negative n, and then 9 to the second. And we also have this 4 will split up to 4 to the n times 4 to the first, which I'll just leave as 4. Okay. Now we're going to just separate this stuff out to make it easier to work with. I'm going to leave the constant terms up here. 9 to the second is 81 times 4. And then 9 to the negative n is the same thing as 1 over 9n. And I also multiply that by 4n. Now, at this point, I'm going to want to, multiply the like terms together. Anything with a variable exponent, I'm going to combine. Anything without that variable exponent, I'm going to just, leave as is. So this is what I'm interested in combining. And I'll get 4 to the n over 9 to the n. And this, like in the previous problems, I can factor out the, well, not factor out isn't the correct term, but, take out that exponent. It's a common exponent. And now I have this. This would all multiply to a constant term. And this is our ratio. And since the absolute value of 4 over 9 is less than 1, our series converges. And then I'll leave the exercise of figuring out what it converges to. It's really just, substitution of two terms. One of them you already have. The other one you can figure out by just putting in 3, by substituting 3. Should be fairly simple. But that's about it. Main takeaway. Your algebra skills need to really be sharp in order to do this simply, right? Like the steps are really not that complicated. And then once you get it into the correct form, checking the conditions, the actual calculus, super simple. If there are any questions, drop something down in the comments below. I'll answer it. But that should be about it. Good luck, guys.